So we're going to solve for molarity or volume in acid-base reactions using our new equation N1M1V1 equals N2M2V2. So let's look at the first problem. 1.40 molarity aqueous sulfuric acid reacts with 40.0 milliliters of a 1.75 molarity aqueous potassium hydroxide to create water, potassium sulfate. What is the volume of the aqueous sulfuric acid? Before we solve for anything, let's have a balanced reaction. So let's do that. To balance this reaction, we have to have a 2 in front of potassium hydroxide and water. Now here we can see we don't have a 1-to-1 of coefficients throughout the reaction. This means we can't use our old equation M1V1 equals M2V2, forcing us to use stoichiometry to solve this problem. But instead, let's use our new equation to solve for this problem. Now, let's assign the values in this problem according to our new equation. So for sulfuric acid, we're given that its molarity is 1.40 and its volume is unknown. So for sulfuric acid, we'll label its molarity M1 and its volume V1. And for potassium hydroxide, we're given that its molarity is 1.75 and its volume is 40.0 milliliters. So for potassium hydroxide, we'll label its molarity and volume M2 and V2. Now upon assigning these labels, we see that we have to only find the values of N2 and N1 now. This can be found by looking at the relationship of subscript and charge in H plus and OH minus in the compounds on the reactant side. Okay? So, H plus with a subscript of 2 from sulfuric acid will solve for N1. And OH minus with a subscript of 1 will solve for N2. Now, the reason we can use our new solution-dilution equation for this problem is because the relationship of subscript and charge for solving for N accounts for the different coefficients in the reaction. Alright? So, the equation for N is N equals absolute value subscripts times charge. Okay? Alright? So let's solve for N1. Alright? H hydrogen in sulfuric acid has a charge of 1 and a subscript of 2. If we plug this into the equation of N, we get that N1 equals 2. Okay? Now let's solve for N2. OH minus from potassium hydroxide has a subscript of 1 and a charge of -1. So when we plug this into our equation for N, we get that N2 equals 1. Alright, so now that we have all these values labeled according to our new equation, we simply plug them in. Okay? Let's just move these up here. Alright? So, N1 is 2. Alright, M1, 1.40 molarity. V1 is unknown. N2, 1. M2, 1.75 molarity. Right? And V2, 40.0 milliliters. Okay? Now that we see we're solving for the volume for sulfuric acid V1, we simply reconfigure the equation to solve for it. Alright? So here, we're going to divide these values right here to the other side to solve for V1. Okay, so these values cancel out. And now when coming up with the solution for V1, we have to consider sig figs, right? So the values for n are considered exact numbers. So we don't consider them for the sig figs. But when we look at all the other values in the problem, all right, they all have 3 sig figs. So our solution will have 3 sig figs. So upon calculating this, we'll get that V1 equals 25.0 milliliters of sulfuric acid. So today, we solved acid-base reactions, solving for molarity or volume, with our new equation N1M1V1 equals N2M2V2. Thank you.